Okay, so now that we're gonna continue exploring the differences between average rate of change and instantaneous rate of change at one specific point, we're gonna now apply this to average velocity and instantaneous velocity. So your average velocity is just going to be the velocity over a specific time interval. So if we think of S of t as your position function, and t is your time, then your average velocity over a time frame, let's call it between A and B, V sub average, you're going to take the corresponding position value when you plug in B into your position function and subtract the corresponding position value for your A value, and then you subtract the difference in your time. Let's say you want to find the instantaneous velocity at a specific point A. Then as you pick your points so that your time value is getting closer and closer to A, as you pick those points closer and closer to A, you're going to approach the instantaneous velocity. So as the values of t get closer to A, you will approximate the instantaneous velocity. Now let's walk through an example. We have a rock that is dropped from a height of 64 feet, and it's determined that its height in feet above ground t seconds later is given by the position function negative 16t squared plus 64. So what that means is if I plug in the seconds between 0 and 2, it will give me the position above the ground in feet. So it says find the average velocity of the rock over each of the given time intervals, and then we're going to use this information to guess the instantaneous velocity of the rock at time 0.5 seconds or a half a second. So this is the time 49 seconds, and then we have the time 0.5 seconds. We need to find the corresponding value so we can find the average rate of change over that time. So we're going to find the position at 0.5 and subtract the position at 0.49, and we're going to then divide by the difference in the time, so 0.5 minus 0.49. When we plug that all in, we're going to get negative 15.84, and because we're using feet and seconds, this will be feet per second. Okay, now really the speed of the rock is 15.84 feet per second, but the negative just indicates the direction that the rock is moving. Okay, now let's do the same thing for this time interval. We're going to do it from 0.5 seconds to 0.51 seconds. So we're going to find the position of the rock at 0.5 seconds, and we're going to subtract the position at 0.51 seconds, and then we're going to divide by 0.5 minus 0.51. When we do that, we're going to get negative 16.16 feet per second. So the instantaneous velocity has got to be somewhere between negative 15.84 feet per second and negative 16.16 feet per second. So a good guess for an instantaneous velocity at 0.5 seconds, just at that one instant, a good guess would be probably negative 16 feet per second.